Okay, so to do this analysis, you have to determine the internal shear force and the internal bending moment first for this beam. Okay, if you start from the left, this beam. Okay, this beam is, the condition is actually like this. So you have 20 kilonewton here, and then you have a reaction force B here, but you don't know. And then you have 40 kilonewton here at point C, and then you have a reaction force at D, in which that you don't know. So because okay, so this direction we will take as positive, this one is positive, and then this direction we take as negative. So the summation of all forces, the summation of all shear forces in y direction should equal to 0 in order to be in a equilibrium state. So it is equal to 20 kilonewton plus minus reaction force at B plus 40 kilonewton plus minus reaction at D, because this direction is going up, so that's why it is minus. So this is equal to 0. So what we got is minus RB minus RD is equal to minus 60 kilonewton, or RB plus RD is equal to 60 kilonewton. But we cannot solve this problem yet because we do not have enough information. So in order to solve this problem, you find the summation of all moment should also equal to 0. So let's say you take moment at point B, or you find moment at point D. So let's say I calculate moment at point B should be equal to 0. So if moment at point B, so if you consider this direction as positive because the shear is going downward, so this is moment at point B should start from the left, which is 20 kilonewton. So because this will cause the moment going to this direction, so it is positive. So 20 times 2.5, okay, and then at C, because this direction is going this direction, so it is negative, minus 40 times 3, and at point D you don't know, so this direction D is going this direction, so it is positive, so plus RD times 5 meter equal to 0. So you got this one is equal to 50 minus 120 and plus 5 RD is equal to 0. So RD you get 14 kilonewton. So when you get RD is equal to 14 kilonewton, so you put this equation into this value, and then you will get RB is equal to 60 minus RD, in which RD is 14, so you get 46 kilonewton. Okay, so you put this value into here, RD, because this is RD. So RB is equal to 60 minus RD. So that's why you got 46. Okay, so now you know this is actually 46, and this is actually 14 kilonewton. Okay, next, you section the beam. You section the beam and apply equilibrium analysis on resulting free body. Okay, so this is so I write here, I draw here. So this is your beam. Okay, or maybe we can write here. We can actually write here. So 20, 46, 50, 15. Okay, so you section the beam and apply equilibrium analysis on resulting bodies. So first, you section at point here, at point 1, at each of these given forces. So at point 1, so summation of all forces in F, or summation of all forces in Y direction should equal to 0. So the so if you refer to that sign convention that I told you before, so this is your part that you shear, and this is 20 kilonewton. So the shear is occurred here because you section, you cut into section, you section your beam here. So this is equal to V1. So when the shear occur downward, the moment occur into this direction, in which that we call this SOM1. So this is V1. So this all the summation of forces in Y direction is equal to 0. So this is equal to this is a minus 20 because it is going downward, minus 20, and then plus with minus V1 because this is also going downward because we section this here, and then this should equal to 0. So V1 we get it is equal to minus 20 kilonewton. And then M1, the summation of all forces of moment should be equal to 0 as well. So moment at point 1 should be 20 kilonewton times the distance is 0. Okay, so the distance here is 2.5 meter from here to here, and then from here to here is 3 meter, and then from here to here is 2 meter. Okay, so 20 times 0 and then plus with M1 equals 0. So M1 is equal to 0. Okay, and then we move to the second point, which is this one. So you cut section before the second point. So this is your cut. Okay, so here we have 20 kilonewton. and then you have your shear force, which is V2, and the moment still going this way, going this direction, which is M2. So all the summation of all forces in y direction should be equal to 0. So this is a minus 20 kilonewton because this one is going downward. Okay, this one is going downward. Minus 20 kilonewton, also plus with minus V2. So it is minus V2 because the direction is going downward. So should be equal to 0. So V2 we get is equal to 0. Oh no, V2 is equal to 20 kilonewton. Sorry, 20 kilonewton. Okay, similarly, so for M, for moment, the summation of all forces, the summation of all moment should be equal to 0 in order to be in equilibrium state. So moment at point B, which is here. So even though you section it, so you assume that it is actually here. So it is 2.5 meter away from this point. So for moment at point 2, so it's equal to, if we consider this direction as a positive, so this will bring moment at point B from 20 kilonewton from point 1 into the counterclockwise, which is this direction. So it is positive. So 20 times the distance is 2.5. Okay, and then plus with M2 equal to 0. So this one is positive 20 because here if we take moment at point 2, so this will bring this beam into this direction because this one you push down, so into this direction, so it is actually in the same direction. So that's why it is positive 20 times 2.5 because the distance is 2.5. Moment is force times distance, and then plus M2. So you got M2 is equal to minus 50 kilonewton meter. Okay, so that is for point 2. So this is for point 1, and this is for point 2. Now for point 3. Point 3 is actually here. You sectioned just after the point B. So you got 20 kilonewton here, and then you got actually RB here, which is 46 kilonewton. At this point you don't have the RB yet, but at this point you already have the RB because the point that you section is actually passing through the point B. Okay, and then the sectioning occur here, which is V3, and then moment 3. So the summation of all forces in y direction should equal to 0. So this is equal to 20 kilonewton minus 46, and then plus, plus V3. So if you consider going downward as negative, if you consider going downward is negative, you put if you consider going downward is positive, you okay, so if you consider going downward is positive, so this one is 20 minus 46, and then plus V3. Or if you want to consider this, because in point 1 we already consider going downward as negative, so we take the same thing. Okay, it is different from the previous example, previous determination, I think. Okay, so it's equal to 0. So V3, we got, it will be equal to 26 kilonewton, because this one is 20 minus 46 is 26. So I hope you understand this one, because this one in here we consider going downward as negative. This forces going downward is negative and going upward as positive. In previous calculation, when we determine this value, I think we assume going upward as positive and going downward as negative, and going upward as positive, as negative, and going downward as positive. So it's actually the same. No matter how you assume, you will end up actually the same thing. So in this example also, if you want to consider going downward as negative also can, or going downward as positive also can. No problem. Okay, and then at this point you finish V3, and then find summation of all moment at point 3. This is point 3, this is point 3, this is point 2, is equal to 0. So moment is equal to 20, because the direction will bring this beam to this direction, so it is positive. 20 times the distance is actually 2.5 to this point, so this is 2.5 times 2.5, and then you have this RB, which is 46. So 46 will give to this direction, which is opposite to this M3. So it will be negative, minus 46 times 0, which is the distance is 0, and then plus with M3. So you get, so I continue here. So you get M3 is equal to minus 20 times 2.5 plus 0. So you get minus 50 kilonewton meter. Okay, and then point 4 is here. So at point 4, so you have 20 kilonewton here, and then you have 46 kilonewton here, and then so this is your V4 and then M4. So the summation of all forces in y direction is equal to 0, and if you consider going downward as negative, so this one is negative, minus 20 plus 46 minus V4 is equal to 0. So you get V4 is equal to 26 kilonewton, and then summation of all moment is equal to 0. So if you consider this as a positive, so you will get 20 will be positive because it is the same direction. So 20 from here to here, it is equal to 2.5 plus 3, which is 5.5 meter, and then you minus with 46 kilonewton times 3, because the direction of this point B is going this way, so which is in opposite, and then you plus with m4 equal to 0. So m4 you will get the value is 228 kilonewton meter. Okay, and then just after the 40 kilonewton force, you cut another section. So at 0.5, this is 0.4, this is 0.5. So this is 20 kilonewton, this is 46 kilonewton, and then you have 40 kilonewton here, and then you have V5 here, and also moment at 0.5. The summation of all forces in y direction is equal to 0, and then you get, if you consider going downward as negative, you get minus 20 plus 46 minus 40 minus V5 equal to 0. So V5 is equal to minus 14 kilonewton. And then the moment, summation of all moment is equal to 0. You get 20 times 5.5, because the distance from here to this point is actually for 5.5, and then minus 46 times 3, and then at 40, at this point 40, so it must be positive. So it must be positive because it will give, it will go to this way, because our section is actually here. Our section is here, so it will be bring to here. So this is positive, which is plus 40 times 0, because the distance is 0. So it should be equal to plus m5, and then equal to 0. And then m5 you can get, if you calculate, you get 28 kilonewton meter. Okay, and then you continue with point number 6. Point number 6, which is here. You section point number 6 is here, so just before the 14 kilonewton. This is 20 kilonewton, this is 46 kilonewton, and this is 40 kilonewton, and you have section here. So moment, no, forces, all forces in y direction equal to 0. So you get, if you consider this negative, so this is equal to minus 20 plus 46 minus 40 minus V6 equal to 0, because we have V6 here. So V6 you get minus 14 kilonewton, and then summation of all moment is equal to 0. So if you consider this as a positive, you will get 20 times 7.5, because the distance from here to here is 2.5 plus 3 meter plus 2 meter. So you get, so yeah, this one, so it is 7.5. So that's why 20 times 7.5, and then minus 46 times 46 times 5, because it is 3 plus 2, and then 40 is positive because it will go to this direction. So 40 times 2, and then plus with plus with V6 times 0, and then plus M6 equal to 0. So you get M6 is equal to 0. Okay, so now you already got the shear force and also the value of moment. Okay, so now because you already calculated the value of shear force and also the bending moment, you can summarize it here from what you have calculated. So V1 what you got just now is V1 is 20 kilonewton, V2 is equal to 20 kilonewton, V3 equal to 26 kilonewton, V4 equal to 26 kilonewton, V5 equal to minus 14 kilonewton, and V6 equal to minus 14 kilonewton. And then M1 you got equal to 0, M2 equal to minus 50 kilonewton, M3 equal to 26 kilonewton, M4 equal to 20, oh no, sorry, M3 is equal to minus 50 kilonewton meter, and then M4 equal to 28 kilonewton meter, M5 equal to 28 kilonewton meter, and M6 equal to 0. Okay, so supposed to be you should draw your shear and bending moment diagram just below the beam, just below the drawing of the beam. This is the drawing of the beam, 20, and then this is 46 kilonewton, and this is 40 kilonewton, and this is 14 kilonewton. Okay, so this is your shear diagram. This is 0. Okay, this is 0. So for V1 which is here is 20. So V1 is actually minus 20. I make a mistake here, and then V2 is also actually minus 20 because we calculated here. So you see V1 is actually minus 20, and then V2 also actually is equal to minus 20. So because minus 20 kilonewton minus V2, and then minus V2 is equal to 20 kilonewton. So V2 is actually minus 20 kilonewton. So V2 is actually minus 20 kilonewton. So this is point 1 is in here, and then point 2 is 20 kilonewton. So 20 kilonewton, let's say in here, and then V2 is around here. So this is 20 kilonewton, and then V3 also. So this is 20 kilonewton minus 20 kilonewton. So because of there is no load between point 1 and point 2, so the shear force diagram is actually a straight line. And then V3 is a positive 26 kilonewton. So positive 26 kilonewton, let's say in here. So this is for V3. And then V4 is 26 kilonewton. So 4 is here. So you get a straight line because from point 2 to point 3 there is no forces there. So the shear force diagram is a straight line. And then V5 you got minus 14, so let's say this is minus 14, so this is minus 14, and then V6 is also minus 14, so this is 6, so it's a straight line. Okay, so this is negative, this is positive, and then this is negative. And then the moment, bending moment diagram, because we have calculated, so this is 0, this point is 0, so this is moment, and this is shear. Okay, so M1 is equal to 0, so it starts from here, and then at point 2, which is here, it is equal to minus 50, so minus 50 is here, and at point 3 is also minus 50, so let's say this is point 3, this is minus 50. So wherever we are getting shear force as a straight constant line, so if the shear force is a straight constant line, the bending moment is an inclined line. So because of this, from 1 to 2 or 1 to 3 is a straight line for the shear force, so you get this bending moment as a inclined line. Okay, and then we move to M4. M4 is plus 28 kilonewton, so this is 28 kilonewton meter. So this is M4, 0.4, yes, 0.4, and then 0.5 here, 0.5, this is 28 kilonewton, and then M6 is 0. So because this is because the shear force is a straight line, so you get the bending moment as a inclined line, and then you move to 0 because M6 is 0. So this is your negative bending moment, and this is your positive bending moment. So this is your shear, this is your bending moment diagram. So if this is the calculation from the book, so this is how you got this this diagram for shear and moment.